So continuing on with exceptions. So I mentioned at the end of the last program we're going to look at modifying the divide method because the code is a little bit clumsy right now. And you can see that we've actually got two tries. We've got a try block on line 19 that ends with the catch on line 24. And we've also got another one starting on line 26 and finishing on line 30. So there's no reason why we can't combine those into a single try-catch block. And in fact, that's the recommended way of doing things. So to change it, it's actually quite simple because we just really need to add another catch statement here. So we'll put catch. We've already got no such element exception caught there. So we'll do a catch arithmetic exception E here. And we can literally just copy the code that was in there and paste it into there like so. And obviously we've got a catch here that we don't need anymore. But before we do that, I'm just going to copy this code also. That was in the second part. I'll paste that into the try block and likewise for the result as well. And paste that in there. That means we've now got this empty try catch, which we can now delete. So that's actually a much neater way of doing things, and the main code of the method is all in one place as well, so it's a lot easier to read. So you can sort of see at a glance that the main part of the code is on line 20 to 23 now. That's the code that's going to be executed if there aren't any exceptions, and the multiple exceptions that are caught through lines 24 to 27 makes it clear what we're trying to actually catch, the potential errors that are there. So when an exception happens, each of the catch blocks is checked in order to see if one of them handles the particular exception. So as soon as a catch that handles the exception is found, that code is actually executed and any remaining catch blocks are ignored. So that's just an important thing to remember there. Now starting with Java 7, it's actually possible to handle multiple exceptions with a single catch block. And I'll actually be showing you how to do that a little bit later. But here, that wouldn't have been appropriate because we want to place additional information in the exceptions before throwing them. So the program should now behave as it should do, with the final decision on what to do about exceptions where it belongs is actually now in the main method. So basically here we can decide how we're going to actually cope with a particular error. Bearing in mind that we're now throwing the errors, we're not dealing with them as such in the divide method. So what I'm going to do now is actually put some code in the main method itself. So let's actually look at doing that. So we can put try. We're going to put the 2 lines of code there into the try. And we're actually going to catch arithmetic exception. We're actually going to print out e.toString, and you'll see what that looks like shortly, which is sort of a dump of the error, the exception rather, and we'll actually print out a message to the console as well. So something like unable to perform division, autopilot shutting down, pilot shutting down, like so. So let's run the program and just try a few different combinations to see if it actually works. So if we enter some valid code first, 10, well, valid numbers I should say, 5, that works correctly. And let's just try putting in some random stuff. Please enter numbers only using the digits 0 through 9. And obviously we can't proceed until we actually do something, 100. And we'll just make sure the second number is also working. That's working fine, 50. That's working okay. And let's continue on. And let's do the equivalent of a Control D, which is Command D in a Mac. Need to be in that window first. And we now got the right error. You can see how we've actually caught the error. The error was thrown for arithmetic exception on line 32. And we've now caught the error in our main method. And it's now being outputted. The catch block for the arithmetic exception the code on line 17 and 18 is now being performed when we exited out that way. No suitable input was actually found. So that's actually correct. So now that's pretty well all there is to exceptions. So I haven't mentioned the differences between checked and unchecked exceptions, and I will be doing that later. But that's certainly enough to be getting on with what we come to look at in this section, which of course is input-output operations. Now you will get some more practice with exceptions in the next few videos, and because we'll be using real numbers and performing operations that actually throw exceptions, we won't end up with such a contrived example that we've actually got here. But it has served, this example, to introduce the concept of exceptions and how we can handle and throw them, though, and even if the use of them to this extent has been a little bit over the top. And in fact, you wouldn't probably bother catching the exceptions in the divide method in a real-world application. Probably a more realistic way to handle this would be to remove all the exception handling from divide altogether and then catch them both in main. So probably you'd end up in a real-world app getting rid of the catches here altogether. So just basically having the 4 lines of code. I'm just going to comment them out now so that they're there if you need to download the source code. But that's probably what you would actually do. You'd have something like that. That's for those 4 lines of code. Then in the main method, and this is the way to actually catch multiple exceptions. Logical OR, no such element exception. So there's the 2 errors there. And I need to make a change to this because this is a feature that was introduced in Java 7 and it looks like my source isn't selected at that level. So I just need to go into there and make that change. So open source settings, project, and I need to change that to version 7. Well, I'm going to actually change it to 8, which I've done in the course. But if you get that error, it's relating to something that was introduced in Java 7, but obviously version 8 will work as well. And you can see the error's now disappeared because we've done that. And I think I might have said that was a logical OR, but of course that's a bitwise inclusive OR, so it's not the standard OR that we use, the conditional OR, where for 2 pipe characters we're just using the 1, which is a bitwise inclusive OR, and that's the way to actually check for multiple exceptions. So this is how you would what you'd probably do in a real-world application. And we'll run this. Still obviously works. But if we put in some invalid input, do my Command D, no such element exception, so that's still being caught as you can see, but likewise, if we put some invalid number in, we're still getting that coming back because we're putting in some invalid number in, and we should be able to then put a 0 in, and we still get our arithmetic exception. So basically, this code can be read, you'd read that as catch arithmetic exception or no such element exception, but again it's the single pipe and not the double pipe characters there. Now I just showed you that if there was an error coming up with multiple catches are not supported in this language level, you need to go back into the project structure as I did and make sure that you're using at least Java 7. But in fact in this course we've been using Java 8, and I do recommend you select that because obviously Java 8 has got all the features that Java 7 had as well. And just a confirmation, the reason we needed to do that was this catching of multiple exceptions on one line or in one catch block wasn't an option until Java 7. Alright, so now that you've seen the basics of catching exceptions, it's really time to move on to I/O in Java. So when dealing with input and output, there's so many things that can go wrong, and so we'll have plenty of opportunities to examine exception handling in much more detail. So I'll see you in the next video.